Hello everyone. Today we are going to design FSM to check whether the decimal numbers are divisible by 2. First of all, what is FSM? FSM is a machine that consists of two functions, machine function and a state function. So in that machine function, what is I? I is the input symbol. What is S? S is the final set of states. And what is O? O is the output symbol. Now, first of all, we should know what is I in our question. So I in our question is given as a decimal number. So the I will be a decimal number from 0 to 9. Now, to check the divisibility, first of all, we should solve this question in a normal method. Normally, we are going to check the numbers, whether the numbers are divisible by 2. So how we are going to check that? We are going to check by dividing the number by 2. For example, 0 divided by 2, 1 divided by 2, 2 divided by 2, 3 divided by 2, 4 divided by 2, 5 divided by 2. After dividing the number till 9, we came to know that there is two group is formed. One containing the number from numbers 0, 2, 4, 6 and 8, which are divisible by 2, having the remainder 0. Other set of group is 1, 3, 5, 7 and 9, which are not divisible by 2, having the remainder as 1. Here we can see that the remainder 0 group is known as remainder 0 group. Remainder group 1 is 1, 3, 5, 7 and 9. Now we have clubbed them together, and how these groups are going to be used? These groups are going to be used for designing the FSM. So here the I is divided, which consists of number from 0 to 9 into two groups, as one group with remainder 0 as 0, 2, 4, 6 like that. Remainder 1 group will be 1, 3, 5, 7 like that. Now what about the states? The states are the condition on which we are judging whether the number is divisible by 2 or not. So here the states are R0 and R1. Now what will be O? O will be the output. What kind of output we are getting after dividing the number by 2? For example, if we are dividing 2 by 2, so the remainder is 0. So this 0 we are going to consider as your output. If we are dividing 2 by 3, so what kind of output we are getting? We are getting output as 1. So output 1 means not divisible by 2. Output 0 means divisible by 2. Now after finding this set of inputs like 0, 2, 4, 6, 8 and 1, 3, 5, 7, 9 plus the state R0 and R1, we are going to design machine function and state function. Machine function consists of inputs. Here the inputs are listed here: 0, 2, 4, 6, 8, 1, 3, 5, 7, 9 into two groups, and the states are marked here. Now what we are going to do, in these cells we are going to write down the output in the case of machine function, whereas in the case of state function is similar to machine function, where the inputs are listed row wise and the states are listed column wise, but at the as a cell we are going to write down the states. So how will we start? We will start by writing the outputs in the machine function and state in the state function. So previous remainder is 0 and the next value is 0. So the new number that is created is 0. So the 0, R0 with 0, what kind of output? That a number is generated is 0. Whether 0 is divisible by 2? Yes, with the output as 0. Okay. Now we are going to fill the state functions simultaneously with the previous value as 0. Remainder R0 means the previous output is 0. With the 0, with the next input as 0, what will be the state? The state is from the current state that is divisible by 2, the next state, because 0, 0 will make number 0. Whether number 0 is divisible by 2, so the next state will be R0. Now in the same case we are going to consider the next value. The next value we are going to consider with the previous value as 0 and the next bit as 2. So the previous value is 0 means the output is 0 and the next value 2 will make the number 2. And the number 2 is divisible by 2, yes, generating remainder as 0, which is already listed here. Now the previous value R0 with the output 0 and the next value is 2 again. What will be the next state? The next state will be remainder 0, that is also listed here. Now again we are going to consider R0 with the next bit as 4. R0 with the next bit, R0 will produce output 0 and the next bit as 4 will make the number 4. But the 4 is divisible by 2, yes, generating the output 0 and the next state will be R0. Now we will check the next bit, that is the next cell with R0 and the next bit as 1. With the R0, previous output will be 0 and the next bit as 1 will make the number 1. But the number 1 is divisible by 2, no, leaving the output as 1. Now we are going to consider the state function. R0 with the next bit as 1 will go to from the divisible state to the non-divisible state because the output is 1. Output 1 represent remainder 1. So it will go to remainder 1. Similarly, if we are going to consider for the next bit as previous bit as R0 and the next bit is 3. So it will make previous bit is R0, that means remainder 0, value 0 with the next bit as 3 will make the number 3. Number 3, whether divisible by 2, no, leaving output as 1. In the state function R0 with the previous value and the next bit as 3, what will be the state? State will be with the remainder 1. Remainder 1 is indicated by R1. Similarly for R1 with the next bit as 0. R1 represent previous value, output is 1 with the next value as 0 will make number 10. So R1 with 0, number 10 is divisible by 2, yes, with the output 0. Now in the state function R1 with the value 0 is divisible by 2, leaving to R0 state. Similarly R1 with 2. R1 means previous output is 1 and the next bit is 2, so we'll make number 12. So what is going to make is going to check, we are going to check whether 12 is divisible by 2, yes, it is divisible by 2, leaving the remainder 0 and the next state will be R0. Now R1 with 1. R1 means the previous value is 1. So previous value is 1 and the next bit is 3. So suppose for example we are taking 3. So what will the remainder? Remainder will be 1 and the remainder 1 state is represented by R1 state. So this condition we are going to check with this kind of thing, we are going to check with the remaining set of bits also. R1 with 5. R1 with 5 will make number 15. Number 15 is divisible by 2, no, leaving the remainder as 1 and going to the state as R1. Similarly for R1 with 7 will make 17, leaving the remainder 1 and going to the state R1. So this is how we are going to complete our table. After completing our table, what we are going to get? We are going to get this kind of table. So from this table, what we are going to do? We are going to draw the state transition diagram. For drawing the state transition diagram, the circles represent the state and an arrow on the initial state has to be always there. So an arrow attached with any state represent the initial state. From there we are going to start drawing or reading our diagram. Now from your state transition tables, that is from the machine table, we came to know that the 0, 2, 4, 6 on R0. So this input bit with R0 produces what output? So we are going to attach output here. That means we are going to write the input and output pairing near the string. So the R0 state with the input 0, 2, 4, 6. From the machine function we will get this kind of output. From the machine function input we is going to generate the output. Okay. Now from the state function, what we are going to do, we are going to find out where it is going actually. So the R0 with the input 0246 is going to itself. So this we will came to know from the state function. Okay. Now next, after drawing for 0246, we have to jump to the next input alphabet, that is the next group, which is 13579. So the R0 state with 13579 is going to generate output as 1, but it is going to the state R1. Similarly for R1 also, R1 with 02468 produces output 0. So we are going to write this thing near to the state R1, but where it is going? It is going from R1 to R0. That's why we have drawn this kind of arrow. Now again from the state function, from the machine function, this input 13579 on R1 with input 13579 produces output 1. This is from machine function. Now from the state function, R1 with the input 13579, where it is going? It is going to itself. That's why we are having this low. This is how we are going to generate. We have generated Fsm for checking the binary decimal number divisible by 2. Thank you.